Anything soft. Yeah. Eh? Yeah, that's good. Get you some of the something advice. Hello, good evening, everyone.
Good evening.
Everyone, yeah, is safely in a position and not in the rain getting wet or not traversing. Anyways, I'm a bit start and I'm trying to finish up by 9 o'clock because I have another engagement. So let's get going. Just a minute there. Okay, sorry about that. So today we're gonna venture into the starting system. I'm gonna implore you all, if and when we hit a topic and you find that we don't conclude the topic, right? And if there's anything else that you're not fully understanding, let me be aware of it so that we can talk to everybody in a class. That we can address it. Some of the stuff you will have to take some initiative, however, and do some research and catch up on the rest of stuff. All right. So we're gonna delve a little bit inside the starting system. So the content is starting system principle and starting motor construction. Okay. Excuse me. Starting system principle. Starting system use battery power and an electric motor to turn the engine. Crankshaft by crankshaft or engine starting. Right? So the means of turning the crankshaft to start the engine is via the starter motor. Of course, we have some control in the circuit. So it's a pretty much basic starting system, right? The ignition switch energizes the starter solenoid. The solenoid energizes the starter motor. So we can look on some key components within the system. So we have our source, and this source is it could be a 24 volts, 12 volts, or a 6 volt, but we have a battery, right? And we have a ground feed to complete the circuit. So this circuit is also grounded through, just a minute, please. Okay, sorry about that. So we have our source here, which we must verify as we begin to deal with anything electrical. Remember, we said that we must verify our source, which is our voltage from our battery. We must also verify our load, right? And the load comes through the starter motor via the starter solenoid, right? We have the insulator, which is the wires. That would be the road that the electron travel on. And then we have our frame, which is our ground. And you notice we have this ground here, and we also have another ground here. So remember, any arrow, the ground is at the bottom of any circuit. So we have a ground here, which grounds what? The starter motor itself, We have a ground here, which also grounds the load, the controlling device, which is the solenoid. And we also have a part to ground right here from the battery. Right, so we turn the ignition key, energize the starter solenoid, which in turn closes the contact and send the 12 volts out to the starter motor for it to turn the starter pinion gear, which in turn turns the crankshaft or the flex, the flywheel or the flex plate. Okay, so yeah, this is just to go through some of it. We've been through that. The key components, the battery, which acts as a voltage source, the ignition, which allowed the driver to control. So that's a controlling device, would be the ignition switch. And the solenoid, it would be a high current relay. And the starter motor, which produce higher torque for the electrical motor. All right, so starting system energized. With ignition key in start position, current flow through the solenoid coil. Magnetism closes the solenoid contact, connecting the battery to the starter motor. And the motor then in turns turn the ring gear and the flywheel ring gear. So that we have also been through also. So starter system D, starter system de-energized with the ignition key release, to run position. So after you go start and you release the starter key, the key, it goes to run position. So here we are now distinguish between two positions. We have a start position and we have a run position. I think we did explain that before, but we're going to go back to it in a bit. Right? So at this point, there's no current flowing within the solenoid. So actually, the contact on the solenoid will actually turn, stop turning, and it will go back into its resting position, right? Moving out of the way of the flywheel, right? So if you release the ignition key and the starter is still running, it tells you something. That one out of two things: the starter is not properly aligned, or the gear, the pinion gear is the incorrect pinion gear. It doesn't match with the flywheel, so it's still stuck in the flywheel while the power is off, right? Or it could mean that something inside the starter motor itself is loose and it's unable to de-energize the starter or to carrying back the pinion gear via the fork, right? Oh, sorry about that. So like we were saying now, there's a difference between the starting position and the run position. So when you turn the engine over by the starter, once it passes 400 RPM, that engine should be running. Below that, it's just cranking. So if it don't meet 400 RPM, the engine will not run. Right? So there's a big difference between starting and running. So the vehicle could start and not run. So you have to be mindful of that when you have a situation, because that could be coming from anywhere except from the starting system itself, apart from the starting system itself. So starter motor fundamentals. So the starter motor converts electrical energy from the battery to mechanical energy to crank the engine. So that goes directly to the crankshaft for engine revolution. Right? And this is where we produce some signal from the mechanical operation to help to stimulate run position. It also produces a turning force through the interaction of magnetic field inside the motor. Magnetic field action that is made up of invisible lines of force. Since since like charge field repel each other and unlike charge field attract each other, the magnetic field can produce motion. So this is the diagram of the poles, the south pole and the north pole. Right, so you have there a magnet, right, and then you have the direction of current flow through the wires, and the field around the wires in the magnet act on each other. Yeah, so this is what the simple electric motor looks like through the electromagnetism. If a current carrying winding is placed inside the magnetic field, the winding rotates away from the pole shoe. From the pole shoes. Commutator and brushes. Keep a motor turning. This is supposed to read to keep a motor turning by controlling the current flow to the winding. Together, they serve as a sliding contact between battery power and the winding. Okay, so this is a pictorial view of the commutator which reverses electrical connection with the loop rotating around. So you have the current, the battery positive right here. This would be a source. And this would be the commutator. Right? This ring would be where you would have your brush contact, making contact, and you would have the insulation right here to prevent anything from shorting. Right? And this would be your conducting winding and your magnet. So to increase motor power, now what we can do, there are several things that you can have several loops of wire and a commutator with more segment. So the segment is a small divider within that goes around all the way around to the commutator. Right? And this is used to increase the motor power. So the more segment you have, is the more powerful the motor will become, because you're generating more electricity. As the motor spins, many windings contribute to the motor. Armature. The armature supports the windings. Iron core increases the strength of each winding's magnetic field. So if you have the wire and you put iron core, then you will increase the flow of electron. Field windings. So you could have stationary insulated wires wrapped in a circular shape around the iron pole shoes. When current flow, a magnetic field builds. So it's a buildup of magnetic fields. This field acts against the armature. This field acts against the armature field, producing a motion. Okay. All right, so this is pretty much the armature right here. So these spacing here would be the segments, right? And this would be the commutator. So the segment would be on the commutator, right? And the brushes make contact to the commutator and the armature, right? So this is your field winding, right? And this could be through wires or it could be through a magnet, right? And this is your pole shoe, whether south, north, or south. That would be your pole shoe, right? The starter pinion gear, it's a small gear on the armature shaft, which engages a large ring on the engine flywheel, which in turns move and mesh with the flywheel gear. So through this operation, now you have the small gear making contact with this big gear to get that strength to turn the engine over its dead and idle stroke. And this is what the starter gear will look like. So on it, you have the gear itself. And this is what you would have making contact with the ring gear and the flywheel or on the flex plate, right? And inside this you have an overrunning clutch. And this here now will be where you have, this will be your armature, and these are the segments on the armature, right? So you have, this is your, hold on, no, this is not the thing there. Here, this is the overrunning clutch. Okay, this is the field pole. Sorry, that's the field pole, right? And this is the armature right down here. This is where your brush make contact right here on the armature. So all of this is part of the armature. Wherever the field is, the magnetic field and the commutator. So all of this, the circuit is tied within this for the magnetic field, the windings. Yeah, that's good. Okay, so the overrunning clutch is a one-way clutch. It locks in one direction and releases in the other direction. Allow the pinion gear to run the flywheel gear for starting. I suppose it can be done off the screen. I turned it off the screen, without on the screen in front of the TV actually. Yeah, but me can't see anything. So it lets the pinion gear freewheel when the engine starts. So you don't, that's the purpose of the release. So after the engine turn over and start and the power is released, then it freewheels and go back to it and retract to its resting position. So if you are unable to add torque to start the engine, 9 out of 10 chance the problem would lie within the one-way clutch and the pinion gear. So that means it won't be able to lock in the position to turn the engine. So that's a default with the pinion gear. So that would be a replacement. And then I'll do that over this. Yeah. So this you can see that it carries a spring mesh, right? And this is the clutch housing. And this is the covering, the hard covering of the one-way clutch, right? And you can see that it's spring loaded, and it's just like any it's the construction is just like any one-way clutch, whether for transmission, anything. It's just like one way. So you have the roller bearing and you have the spring, right? Also, there's a retainer to keep the spring in position so it doesn't run out of it doesn't comes out of the position that it's supposed to be in. Yeah. So, and this is the engagement flange. So this is another cutaway view. So you can see more of that's the other view of the one way. So you can actually see the spring, the bars, and how they are interlocked with inside the unit. So this is the pinion gear assembly, right? So the pinion gear assembly slides on a shaft for engagement, right? So you have this is the lever. So after you have the magnetic field created through the solenoid, and it close and make contact, then it will pull on this lever that carries it out inside to mesh with the flywheel or the flex plate ring gear, right? And then after it has started, then it go back to the resting position. So you have an engagement and you have a disengagement. So what is a starter solenoid? It's an electromagnetic switch, pretty much like any relay. And so it's a controlling device. So it makes an electrical connection between between the battery and the starter motor. So what I tell you that it is in series with the starter motor and the source from the battery, which is controlled through the ignition switch. So that would fall after the switch, because the switch is where you would get the magnetic field created from that ground source and of course the ignition source. So when that magnetic field is created through that coil and current is induced, then it closes the contact, and whatever you have on the source, then it goes to the output. So if you have a good 12 volts, the starter motor should turn. And this is no different from any other relay. Okay, so yeah. Yeah, so that's the starter motor is solenoid. So okay, so this solenoid looks pretty more like the isolated solenoid. That's the one that's bolted away from the starter motor itself. So this is not one that is integrated on the starter motor, but the function is just the same. So this is where you would have your field coming in. So you'll have your battery terminal, your positive terminal here, right? So you'll have a 12-volt source, and this is the winding, right? So this is where the fields is created. So this now comes back through and make contact on this right here. So if this is not bolted properly on the frame, because this is where the ground is connected. So if it's not bolted properly on the frame, then you won't have no current flowing through. Yeah, you will have a positive, yes, but remember that for anything to work, you need to close. It needs to be closed. The loop needs to be closed. You need to have a ground contact, a ground point. So it's grounded through the body of the solenoid, right? And this would be your output. After the field is created, then the plunger goes down and it closes the contact and energizes the starter motor. All right. So if you in turn have all your parameter for current to flow, and in that flow, in 9 out of 10 chance is that the contact between the dirt between, or you're not making proper contact between these two plates and the plunger and the disc, right? So the 12 volts will carry this, the 12 volts will be right here. So when these two make contact now, the 12 volts from here will be transferred to here, and it goes directly to the starter motor for turning the engine. Okay, so yes, a solenoid operation, pretty much standard low current flow through the windings, magnetic fields, pull the solenoid plunger and the disc together, and the disc touches the both sides of the current terminal, and current will flow to the starter motor. Right, so we can see that we have, yeah. So this is from the same action as the plunger. This is just a line diagram of connecting to the plunger. Right, so we have ignition key and we have the path of current flow. Right, current flow coming to one side of the terminal for the contact and going through, come through the windings, all the way through the windings, right, and come back out, make contact with the disc, and then it energize the starter motor. So we say we definitely have a source here of some kind, and we have a ground right here, which tells you that we must have current flowing through these windings, right? So we could be having current flowing through the winding, but we don't have what to support that. So we need to verify that on one leg that we have whatever our source is, we have that, and then the other leg would be the output. So in checking any sort of relay solenoid, electromagnetic relay, you must check for the source, which would be, most times would be a battery volts. All right, and you will find that on pin number 30, but it left to the relay, the type of relay that you're checking. You may have different numbers as it relates to that. But for like the standard relay, the aftermarket relay that they use every day, you will have numbers that represent the connection. And the numbers will read like 30, 85, 86, 87, 87A. All right, so 30 would be your source, whatever your source will be, and your output comes from your source. So that would be where the plunger would meet. All right, now 85 and 86 would be your ground and your input to create that magnetic field. All right, so 85 would be your ignition. That would act as your input, and 86 would be your 86 would be your ground, or the other way around. I don't remember clearly. I think it's 86 is the ground and 85 is the ignition. All right, so on some relay you will have like 3 and 5 for input and output, and 1 and 2 for the coil. But the design and and the way you go about executing the check is pretty much the same. It's just important that you know what to connect to what number. So you can quickly go to the number. Remember, when we're running any test of any component that uses electricity and as a solenoid as a control, it's always good to start the check at the solenoid so you can check, excuse me, if the problem is upstairs or the problem is downstairs. So upstairs would be your input and downstairs would be your output. Solenoid functions goes to the battery to start a circuit. It pushes the starter pin into mesh with the flywheel ring gear, bypasses the resistance wire in the ignition circuit. Starter motor construction. Two types. Movable pole shoe starter motor and starter mount solenoid. Starter motor with solenoids. That's the one. The integrated. So one is with the which is isolated from the starter motor itself, and one that is integrated with the starter motor. So for the persons who work in farm vehicle, long time would have known the solenoids. They used to call them a Startex. Yeah, but for those who new to the field, probably they don't have that experience. They were more familiar with the solenoid that is integrated within on the starter motor.
Sir.
Yeah.
Sir, now some people call it solenoid. Sodomite.
yeah, exactly. Yeah, because when we were hearing it for the very first time, that's what we heard. You understand?
That is true.
Yes. It's just like when you come to gearbox and we talk about blocker rings. People say barker rings. And people still say barker rings up to today. You understand? Yeah. So this is a pictorial view, of course, of the movable pole shoe starter motor. Right? We can bring this up a little bit for me. Okay. Nobody black out the text. Yeah, so I can do this later and because everything comes up. All right, so you can see at the back right here is where you would have your commutator with the segment, the brush, positive brush, negative brush, right? And this is the frame of the commutator that covers it. This would be the armature, right? And this would be your field frame. Right, your pinion gear, your one-way clutch, and of course, this would be your plunger, right? So the plunger is connected to this the holding pin only pivots. It only pivot to start. It only pivot that, but this is connected to a fork differently. That's when the solenoid is engaged, it pulls on it. All right. So yeah, your overrunning clutch is your one-way clutch. All right. And that's the holding card, that's a hold and release. So this is for energizing and de-energizing the starter motor. There it goes. Go back. Okay, so this is the view of it without the casing. So you can get a pretty much view of it. So this is your pole shoe. One is, and this looks like this carries probably 4 poles. Some carry, so you will have some with 3 and some with 4, but this look like it has 4. There's one here, there's one here, You can see another one down here, and if you look through here, you see the other one. All right? So you have 2 north, 2 south. Okay, so this is the solenoid mounted starter, and this is it's the same function except for the fact that the starter is mounted onto the solenoid. Sorry, the solenoid is mounted onto the starter motor itself. So you could actually do on-demand test, which we call a bench test, a dynamic test, which is also called a bench test. And what the bench test does is isolate the rest of the circuit. So let's say, for instance, you suspect that there's a problem within the starting system, but you can't detect it. So one of the ways that we generally go about isolating the starter is to do a bench test. You could do a bench test. A bench test really means you test the starter on the bench. But you don't necessarily have to take the starter from the vehicle to execute the same test. You understand? So you could isolate the rest of the circuit from it just to ensure that your problem is not the starter. But like I say, if you check at the starter solenoid and you run the check and you run the check well, then you don't need to do that because you'll be able to see exactly what is happening. So what is coming in, what is going out, what you have on the frame if you do, and what you have for your source. Right? Because it could be a case where everything is functioning, but the voltage that is supplied is insufficient to do the work. Right? So we encourage to not just use test lights when doing these types of diagnostics. Right? So you want to look on the numbers. It's important that you know the numbers. Right? And I can tell you that from experience. You understand? The number is important. So you're going changing parts, and you change everything, take out everything out of the car, put in car, and you still have the same problem because the problem don't have nothing to do with parts. You understand? It don't have nothing to do with physical parts, but it's just the voltage that is supplied is insufficient to do the work. Right? And remember, we must verify our source. And the best way to verify our source is to use a DVOM and check the numbers. And you remember now, what's a fully charged battery? And your open circuit voltage, what's a fully charged battery? Hello?
12.6.
All right, good. And a discharge battery is?
11 something.
11.7.
Right.
It's a discharge battery. All right. So we must verify our source, our ground, our insulation, and our main element. Your main element is what again? Remember what is your main element? Your main element is your load. Whatever it is that you are controlling, that's your load. That's your main element. It moved? Oh, it did. So it says solenoid. The solenoid completes the battery to start a circuit. All right. So here we are again. We begin to verify our source. All right. We're verifying our source, and this goes to the pole and to the starter. All right. That's a battery pole to the starter. And this on the other side of the starter would be after you create the field, after you create that magnetic field and close the contact, then whatever is here would come on this side. And when it come on this side, then it means that the starter motor should turn. If it doesn't turn, something else is wrong. Now you will have to do your investigation to find out what is wrong. So once you get the principle, then the diagnosis will be straightforward. Get it? Yeah. Yeah, all right, so this pretty much telling us what we already know, right? So on this, we're looking now that we're seeing that we have a path to current flow. We have a path to current flow, and the path to current flow is that electron flows from the negative side to the positive side. You see, the path of electron flows is from the negative side to the positive, then through the ignition switch to the solenoid, then to the starter motor, which turn that electrical energy into mechanical energy. All right, so the pinion gear now makes contact with the ring gear of the flywheel or the flex plate, which in turn turns the engine. And of course, that is only true and possible if the starter is grounded. You see? So we start here and we end here. So we begin the process here again. And it's a continuous path. All right. Yeah, so this is just the permanent magnet starter using uses special high strength magnet in place of conventional field windings. All right. And pretty much we are just going back through all the components that we know from before. So we have a solenoid coil. The fact though that these are welded connection. You understand? And if it's welded, one of the things that crosses your mind when you have connection that are welded, what crosses your mind? Anybody? Tell me what crosses your mind when you have connection that are welded.
They don't want you to repair it.
Not only that, but we want to ensure that during operation, it can withstand what is passing through it and you don't have any breakage.
Right.
You understand?
Because it don't have any water.
Pardon me?
Well, they're not broken.
I didn't get that. Repeat for me, please.
Okay.
Hello?
No, I was asking. You said it don't never have any something, but someone else answered. So the welding not broken.
Okay. Yeah, sorry. All right. So once you see anything that is welded, one of the two things is that it's for well, most of the time it's because of the amount of current that is flowing through it, the importance of the current that is flowing through it. All right. So makers would stamp that would weld that so you don't have so they don't want you to interfere with that. Because 9 out of 10 times them sell whatever it is, them sell it as a unit. So it's not to be removed and replaced. But you know we're already full of genius. But yeah, sometimes it goes against us. But if we understand why, then we will ensure that whatever we are doing, we make sure that it's holding properly. All right. You understand? All right, starting motor torque. A starting motor must produce high torque. Why do we need high torque? We need that high torque to ensure that we can turn this. We can use a small gear to turn this big gear at a force that it will cause the engine to turn enough to carry the crankshaft over dead and idle stroke. Difference in gear size between the small pinion gear and the large ring gear increases turning torque. Okay, so this is a reduction. This is pretty much a reduction gear starter. So it's a extract gear, further increase torque. So what we're using another gear to increase torque, right? So there's the gear starter. So there's the idle gear, and the idle gear is between the pinion gear and the gear that is on the armature, at the end of the armature. Hmm? Yeah, the pinion gear, pinion clutch. The clutch gear is a pinion gear. Oh no, sorry. This one don't actually act with the pinion gear, because the pinion gear is forward. This is a clutch gear. So what it's operating and it's functioning and the locking mechanism on the clutch itself. Thanks, sir. It's the function surrounds the locking mechanism on the for the turn the pinion, the ring gear and the flywheel or the flex plate. So you will find this on vehicle with greater volumetric efficiency and vehicle that requires more starting power. Faster starting, and it helps with the rate of start and all of that. So you find this probably on big units and on diesel engine that carries a higher resistance through combustion pressure and compression ratio. Internal motor circuits. So you could have a series winding motor, a stunt wound motor, and a compound wound motor. Right? So this is pretty much what a series wounded motor looks like, right? So it develops maximum torque at initial startup and decrease as motor speed is increased. So the shunt wound motor, which pretty much look like a parallel circuit, will produce less starting torque, but more constant torque at varying speed. So this is compounded. So it's compounded between the series and the parallel. So you will have like a series parallel circuit. So it has both series and stunt wounding and produce good starting power and constant operating speed. So all of these will be applied to different engine for different torque and speed, starting speed. Okay, so the neutral switch. All right, so now that we're here, we can go back to the beginning, very beginning. All right, well, I probably shouldn't get. Let me go through this first. All right, so the neutral switch, it's a safety switch. So the neutral switch have a safety to ensure that you're in either park position or a neutral position and the vehicle is safe to start, right? Imagine if there was no neutral switch, there was no safety, and then you could start the vehicle in any gear, and then you could have some issue with the accelerator cable sticking or anything, and the vehicle starts. The vehicle were permitted to start, and it starts in any gear, and it is anywhere, and it's going anywhere. So you have no control. So neutral switch is a safety switch, right? We want to ensure that the vehicle is safely in park or in neutral before we start, right? And in some application, it's used to for other to make other decision also as it relates to control over some systems. Right, so the neutral switch prevent the engine from cranking unless the switch selector is in neutral or park, mounted onto the shift lever or on the transmission. And some late model vehicles, they are built inside the transmission itself. Don't know what stupidity. If you have to get to the neutral switch, you have to pull up the transmission. You have to take out pull the pan, take out the valve body to get to the neutral switch. And some vehicle also, the neutral switch and the computer for the transmission is built inside the, along with the speed sensor, is built inside the transmission itself. You understand? So I try to figure that one out, but I'm not going to read too much into that right now. All right, so the important is that we recognize as a safety switch, and if it's not functioning properly, it could cause starting issue. So that's a part of the circuit, of the starting circuit. Also, is your clutch start switch is a part of the starting circuit as safety also, right? Yeah, I have to go through this before I go back to that because it is too complex. So I have to go through this first. So here is the neutral system. So before we add everything else within the circuit, so the only thing that you're not aware of in the circuit is the neutral switch, right? So if you notice now, the neutral switch, what is this? If you notice the neutral switch now, the neutral switch from the battery to the starter motor, but for the control side now, the neutral switch has to make contact. It has to have a close contact, and the contact only becomes closed when the vehicle is in park or the vehicle is in neutral. Let me tell you. Okay. All right. So if you notice that this, at the end of this, it says start switch. So in some application, especially when you're looking at wiring diagram, you will see some information like neutral start switch, right? Because it's a starting safety switch. And in some application, you will see inhibitor switch, like on some Nissans, the older Nissan. So you won't see like neutral switch or neutral start switch. You will see something like inhibitor switch or inhibitor relay, because it carries a relay for the neutral switch in that application. So this is why we generally consult our service manual or repair manuals for information to know how different vehicles are constructed, how they are function, and how they operated, so we're better able to diagnose and run the check. So do the work properly one time, and we don't have the customer coming back. Very, very important. We do the job one time, and we don't have the customer coming back. We have the customer sending people to us. All right, starter relay. So, all right, so open or close one circuit by responding to another electrical signal from another circuit. Uses a small current, it also uses a small current from the ignition switch to control a large current through the starter solenoid. And this is one of the ways where you can amplify low voltage that's going to the starter solenoid. So if you're having issue with low voltage, then you will have to select a different source for the part to the part of electron to the starter solenoid. And you will have to use something to, and you will have to use a control mechanism. and it reduces the load on the ignition switch. So this is where we control the current flow, so it don't come back and burn the switch out. Understand? The ignition switch in turn starts. Current flows through the relay winding. Magnetism closes the relay contact. Contact complete the circuit to the solenoid winding, operating the starter motor. So it ends at the starter motor. Okay, so this is the same starting system circuit. Let's look and see what's in the circuit that's new. And the only thing that's within the circuit that is new would be our starter neutral switch. And this works only on automatic transmission vehicle. Right? So okay, so this is a starter solenoid now. Right? So the ignition system. All right, so this will be the ideal situation with the low voltage on the starter solenoid that causing poor starting. So what you incorporate now is a starter relay. And you notice the source coming from here now, directly from the battery, right? But directly from the battery now, when it closes contact, it goes where? Directly to the starter solenoid. So here we have our source, right? This is our source right here. This is our input, right? And this is our, input will come from the ignition switch. This would have to be from a ground source. One of these would have to be from a ground source. More like, no, this is from the winding itself. So this doesn't look like the situation we're talking about, because this circuit looks like it's the compounded circuit with both the solenoid and the relay. Remember we're talking about the compounded winding? Yeah, this circuit looks like that, because other than that, we'd have to have a separate ground for that, and it would have to come from this. So this would be the other side. Okay, so we're going to do some testing and repairs. I guess we did some amount of testing already, but let's see what's going with this. All right, so starter system diagnosis, battery cable service, starter solenoid service, ignition service, starter relay service, neutral switch service, and starter service in itself. So let's begin with some diagnosis. So, common problem, no start problem. Do we need to go through that again? Because we did it a while ago. All right? So, this is a situation. The vehicle cranked, but does not start. But if the vehicle crank, okay, hold on. Crankshaft does not rotate, sorry. So it's a no crank problem, and the crankshaft does not rotate. So we did that electrically. So the only thing that we did not do, the only check that we did not run prior to this is a mechanical check. Because the crankshaft it's possible that the crankshaft not turning not because of the starter, but because of defective engine. Yeah, whereas the crankshaft is mechanically not turning because of some binding or some resistance within the engine mechanism. All right, so we have that. We have slow cranking condition. All right, so the crankshaft rotate slower than normal. I remember we talked about that. That could be coming from a voltage source. Insufficient voltage to do the work. Insufficient voltage does not necessarily mean it's on the oxide. You could have a strong 12 volt battery, but you have poor ground, insufficient ground. Remember, the source is equally important as your frame because you must be able to loop it for it to become functional. Right? So this is where voltage drop comes in, and voltage drop is important. We're going to do some voltage drop later down in the session. Right? But this is where it comes in handy. And you can quickly do some isolation and get some things out of the way. Right? So it could be, well, if the solenoid is sticking here, it comes back to your voltage source because of low battery or poor electrical connection, whether it be through resistance or loose connection. Right? Noises caused by overrunning clutch and flywheel tooth gear meshes. We talk about that. So you could have the wrong gear inside it. So they're not meshing properly, or you could have a damaged part that the starter goes out, doesn't come back in, or the starter itself could be misaligned. And when we say misaligned, it could be misaligned in that it's too far, too much in. So some starter, when you buy some starter, they will sell it with shim. And the purpose of that shim is to do adjustments. So if the starter is in too much when the starter release is still running with it, you can remove the starter and add shim to counter that. And some system you will have like what is called wedges. So it will be something that looks like tapered off that carry the starter up from where it's connected. Okay, sorry about that. We have a temporary interruption. We just fix it. All right, so it says common problem, check for these kinds of problem. Okay, so we could have poor battery. And we say the battery operate at its poorest when it's cold. Solenoid could be bad, the starter motor could be bad. The controlling device and some complex system could cause that, because as we get more familiar with electrical and electronics, one of the big things that we have to encounter with is theft. You understand? The more we get sophisticated, the more the thieves get sophisticated. So we have to counter theft. So we have to add different function now for within the starting system. Right? So we can't just cut a key and start the vehicle now. Right? We have to tell the computer. We have to also tell the computer that the key that I am using is the key for the car, right? And that signal will be bypassed and then transfer, right? So that information, basically, whosoever is controlling that mechanism is going to tell the rest of my modules, say, yeah, man, it's okay, man, you can fire it up, man, release the starter signal and turn on the relays. And then some of these systems within the starter, you have more than one relay control in the system, right? So, yeah, we have the ignition switch, right? Could be a problem. The ignition switch in itself, the could be the tumble wheel or the ignition switch itself, the barrel or the ignition switch itself, because they are interconnected, right? And it could be as simple as a misaligned neutral switch or gear shift adjustment or a worn bushing or cable out of alignment. You understand? So we must, in our diagnostic, we must strive to check system. And when I say check system, I mean if this is a system, and for this system, you must know each component within the system. You must know how they operate individually and how they work together for one cause. So when you're doing your analysis, you have to ensure that nothing is left unchecked. You must check everything and you must verify. And if needs be, you condemn. You understand? But if you can't execute the test, then you can't condemn if you cannot prove. So you must prove to condemn. Okay, so we are going to be doing now a starting headlight test. And what that involves is turning on the headlights, try to start the engine. Okay, so the headlight itself draws good amount of current, and the greatest current draw on the vehicle and the system would be from cranking the engine, right? So if you turn the headlight on and crank the engine, that would be your maximum electrical load, right? So if the headlight is on and you crank the engine, them say no cranking with no engine, with no headlight, battery dead. So you can go ahead and throw the battery. So if you don't have no cranking and you don't have any headlight, the battery is dead. I would still check the battery voltage, right? Because even though that might be the case, you could have something else interfering with the light circuit, right? But you have another problem with somewhere else in the starting system. It doesn't necessarily mean the battery dead. But that when you say the battery dead, it means no that you're not changing the battery, but you go and check it. Right? And you know all the tests to run with the battery, your open circuit voltage, your specific gravity, right? And you must measure all of those must be relative to temperature. Right? Headlight goes out when cranking, every current draw, starter, low battery, or engine too hard to crank. Right? So that could be a mechanical problem also. So never rule that out. When you go to start the vehicle, if the vehicle don't want to turn any at all, we must be able to, or we should execute a manual turn of the engine to see if the engine does turn. I always say turn, we don't mean turn part where we need a full 360 degree, right? Because the engine could rock over and jam at a point, but it frees up at another point. So we do a full 360 to ensure that the engine gets a full revolution. Right? So headlight stays bright, but you don't have no cranking. So this suggests that there's high resistance or opening the starter circuit. Right? So it could be as simple as the wire to the solenoid not secure and it jump off. So there's no current going to the starter motor. So there's no current draw on the system. So if there's no current draw on the system, then all lights that were on will still remain illuminated and in full illumination. Fusible links. If major components are dead, check fusible link. And that is as clear as day. if you have something major component within the vehicle, right? And they're not operative, then you could check the fuse just to see if you have a damaged fuse or you have a continuous part within that part of the circuit. Checking the battery. Verify battery condition, and you would have known from the previous class all the relevant tests to execute to verify that. Load test if necessary. All right. Starter current flow may exceed 200 amps, requiring high battery output. So so for different make, model, and volumetric efficiency, the starter current draw is going to vary. So it's always recommended that you check the repair manual or the service manual for that information. So never just take it that one current draw for one starter works for all. For instance, if you have a petrol engine, the starter current draw on it will be less than that of a compression ignition engine. Starter current draw test. Measure the current draw by using the starting system. So to measure the current draw, you have to make sure the engine turns over. Connect a voltmeter and ammeter. Disable the engine. Disconnect the coil, primary supply. Round the coil wire. Disable the electrical pump. Park the engine for 15 seconds. So pretty much what they're telling you to do, they want the engine to be running smooth, fast. They want the engine fast turnover. So you must ensure that you have a fully charged battery, and you must, as best as possible, remove all the load from the engine so the crankshaft can turn easily. Because every load you add to that engine when it's starting, the current draw is going to be greater. Right? So this test is done with all the load off. So it's pretty much as if you were doing a compression test. You want the engine to wind over fast and take in as much air as you possibly can. Okay. So equipment connection. A voltmeter is needed to verify battery condition. And that is just open circuit voltage. On this side, you have a voltmeter, and on this side, you also have an ammeter. So when you're cranking the engine, you want to look and see how far the voltage drops. The voltage should not drop below 9.6 when cranking. If it drops below 9.6 when cranking, then that won't be able to start the engine. And then at the same time, you will take the current draw when the current is flowing, when the starter is drawing the current. So you have the volt and the current amp is going to be only true if the voltage is good. So this is why you want to integrate the voltmeter on it also. Starter current draw test, load test. Crank engine, noting voltage. Yes. Load the battery to the same voltage. Amp will equal starter current draw. So of course this is how you go about doing the starter current draw test. And you will have the information in the repair manual telling you how to go about this and if you should add a load and any particular load that should be added This is a load test condition. So you'll have the load tester, you have your source, battery, solenoid, and you have a starter motor back to ground. So you loop the circuit and you check and see how much you're losing when the starter motor begins to operate. So it's a full load condition and you test the battery under this condition. All right, and so we talk about the value. So this would be the recommendation, right? So I tell you about the engine displacement. So it left to the volumetric efficiency of the engine. So for this, it says for most 4-cylinder and 6-cylinder engine, the current draw the maximum current draw should be 125 to 175 amps maximum. All right. On the 300 CID, 150 to 200 amps max. Over 300 CID, 75 to 250 amps. Cranking circuit troubleshoot chart also gives you a voltage, the amperage, and the possible problem. Right? So it says this voltage is okay, current is okay, the system is okay. But if voltage is okay, current is low while an engine cranks slowly, starter circuit is faulty. And it says voltage is low, naturally current is going to be low. Right? And they tell you that the battery is low. And if voltage is low and current is high, starter motor fault. So it is drawing more, it is using more current to deliver. Oh. All right, good. All right, so this is voltage drop test. And we're just going to go through the voltage drop test, but we would love to get, I don't know if we're going to get to do any practical with that, but that would be good if we could, because that's essential for you to actually get a feel and see and know what happens when those things are happening. So locate higher than normal resistance. When current flows through a circuit, electrical resistance causes voltage drop. So of course you know this, because why we know this? We know that resistance opposes current flow. Sorry. All right, so this is a starting system, and we're doing a voltage drop on the starting system. Now we could do a voltage drop on the component and the individual component within the system. We could do a voltage drop on the insulation of each component or the entire insulation within the system, or we could actually do a voltage drop on the entire system, including all components and insulation. All right? So we could voltage drop the ignition switch. We could voltage drop the relay, the starter relay. We could voltage drop the starter motor alone. We could voltage drop the ground side of the starter motor or the starting circuit. Or we could voltage drop the hot side of the starter circuit. And we could voltage drop the entire starting system. Right? So if we were to look at this diagram, right? So we have our positive meter lead on the battery terminal here, and our negative meter lead is on the hot side. This is the hot side of the starter solenoid, which will be the battery part, the straight battery port. Right? So it's a 12 volts from there. So what we are voltage dropping, we're checking for resistance within what? The insulation. right? Because we should have 12 volts right here, right? So if we have a voltage drop more than 100 millivolts, then you should see it on your meter. Now that is sufficient to cause the vehicle to turn over slowly. Not in any great magnitude, but it could cause the vehicle to turn over slowly. But as the resistance gets higher, the vehicle will turn slower. So generally what we do with that, we take out that cable from the positive battery lead to the starter, and we get rid of it and we change it. And we clean up the contacts, make sure the contacts are tight, clean, and secure, and put them back in. And we rerun the test. We never put things in and figure because we get a bad signal and we put in a new one that everything is okay. We must always confirm the test, right? So the next test we're seeing here is we have voltage dropping the ground circuit, right? Because this is the negative side of the battery. So we have a negative or black meter lead to the negative side of the battery, and our red meter lead to the ground side of the equation. Right? And of course, the other test is testing what? Not insulation, but the component itself. Right? So what we're testing here, we're actually testing the integrity of the starter solenoid. Right? So a voltage drop in the starter solenoid. So if everything here is good from this point to this point, I don't see no reason why the vehicle should not turn unless it have a mechanical problem.
Yeah.
Or is the starter solenoid we think then we gonna check the starter motor then. So if to check the starter motor now, we'll have to put an arm clamp around this wire here and check the starter amperage drop. It's that. Next one. Okay. Insulated circuit resistance test. Connect multimeter between the battery positive and the starter motor terminal. Oh, that's what was been done previously. Right, so it's a crank engine, noting voltage. Maximum voltage drop should not exceed 500 millivolts. That probably work on some system, but not that don't work on nuclear. I can tell you that. You don't want no voltage drop when them starting something then. Why? Because them carry demand so much current for the rest of function with the ABS and all of these things. Power steering, electric power steering and all of them something. You don't want no voltage dropping up and nothing. You better make sure so when you go across that is 0 volts, you see. Alright? So we identify dirty or loose connection burn or pitted solenoid contact. And for those that you can see the contactors for like the reduction gear starter, we have the contactor. Some solenoids are enclosed, so you can't see it. So we just change it, but some of those use contactors that can be replaced with the plunger. Right, test each part if necessary. Right, so generally check everything within the system to make sure say we don't buy something or fit up the vehicle and never go back and pull back down the vehicle. Do the same job twice or 3 times. So we checked because once we pull, we are unable to check. So we check before we pull, and we put back together, we check again. And there's some tests that you can do when it's off the vehicle. And those tests are pretty much just static. Unless you're going to do a bench test where you're going to apply power to the component. Insulated circuit resistance test. Okay, so this test is running. Okay, we're not looking for that. Let's talk about ignition coil and them things. Okay, start a ground test. So we did that also. And again, we don't want to see any voltage drop on that negative terminal of that insulation. Right, you want to make sure so that it's tight, clean, and secure. You want full electron flowing through those connections, to those insulation. Battery cable service. To test connection, connect voltmeter between battery battery post and battery cable. Crank engine, noting the voltage drop. Maximum voltage drop is 300 millivolts, which is 0.3 of a volt. Clean and tighten connection if voltage drop is too high. If cable replacement is necessary, use compatible cable. All right, so oftentimes, even on late model vehicle, a vehicle comes into the shop and you run some tests and you look inside it. When you look, you see the man them take speaker wire. The man them take speaker wire. It was yesterday one man came to me with one electrical problem with him on. And the man them take telephone wire, wind up together and put in the man circuit, you know. These guys are crazy. You understand? And guess what now? There's something run hot and there's no insulation on that. And if something is close to heavy ground panel on the vehicle. These guys are skilled. Are they trying to create a bomb? Oh boy, it's crazy. So we must use the appropriate replacement cable. Right? So everybody have them time and them function. So for those who from the old school and have those cable, them fat cable there with the aluminum with the lead on it. Yeah, nobody use them for them cars. I'm something build up resistance fast and give big problem. You understand? So if you keep the insulation to the component tight, clean, and secure, 9 out of 10 chance you will never build up any resistance. Right? So you will build up some of that resistance coming from when we're creating that chemical reaction within the battery. Where you have the gassing taking place, you may have start to build corrosion around the area. That's why it's important to maintain the hydrometer level, the electrolyte level, and to ensure that the battery is kept clean, both top and bottom, and also to ensure that the cables are tight, clean, and secure. That will help to keep off some of those unwanted resistance. All right, so this is testing the battery terminal for resistance. So you check between the battery post and the battery terminal itself. And this is a common no start or slow start condition. If you develop, and I still see people servicing battery and putting on grease on the battery post before they put on the battery terminal. All right. So obviously they do not know that resistance oppose current flow. So what they're trying to do is get rid of the corrosion, but what you do is make sure you connect the battery after it's clean and the terminal, the post and the terminal are clean. And after you tighten it, then you can apply some petroleum jelly or white grease on the terminal itself, or even go on the post, but not in between the post and the terminal, if you want to get rid of some of that corrosion. All right. Start the solenoid service. Solenoid problems can cause slow cranking. solenoid problem can cause slow cranking, no cranking, or keep the starter cranking after the engine is started up. Large disc-shaped contact can burn and pit. Winding can open or short. So a lot of people will go to a component and they have a problem and they check for open. But how much person check for short circuit or short within the component? Right? So quickly come on, go across and check it. Come on, open or not, but if they don't take for short. You understand? So you must check for open and for short circuit. So we check for open circuit and short circuit also. Terminals, crank engine maximum voltage drop, 300 millivolts, which is 0.5, 0.3 of a volts. Replace solenoid if voltage drop is too high. Okay, so this is the solenoid, and this is where we are executing that voltage drop now. So we are executing the voltage drop to see if there's any resistance that is between the connection right here. So this is the insulation, right, which is the wire, and this is the top of the battery, the solenoid. So we're checking to see if there's any resistance within here. Allow me now in class here. The resistance within that part of the circuit. So the other test is showing now that we are voltage dropping the entire, and this will be the contacting point, because these two would be your the field side, and this will be the contact. All right, sorry about that. We keep getting bumps off. You know, technology goes sometimes.
Sir, yes, sir. It give the same problem, sir.
Yeah, yeah. Yeah, I understand.
Next.
So yeah, go next. All right, ignition switch service. Ignition switch problem can prevent the starter solenoid from working normally. All right, so remember now we talk about that low voltage situation, right? So generally, when we put the ignition on and we go to cranking, right? If you are not very, very careful, that information will slide past you. You never look at that. I never check that. Most of the time when guys check that is after they change every part from the car and them can't figure out what's wrong. Which tells me that they are going about it wrongly. Remember now we say we run all possible tests before we pull. That's when we pull, we know what we're going to look for. When you pull, you can't run up on-demand check. You can't run no dynamic check. Any check you're running when you pull is a static check. Right? And static is only limited. Static is so limited. You're going to tell you say the coil closed or the coil open. But it's not telling you nothing else. It's not telling you functionality. Because it's not on demand. Right? So we run all the tests before we pull. Right? Contact can wear or burn. Open circuit cause no cranking condition. Yeah. Right? Short circuit cause engine to crank all the time. So if it's shorted to power, it's shorted to ground, you will have system in operation all the time. Ignition switch testing continues. Touch a grounded test light to the solenoid. And that's it. For the start position, that would be S. For your start position, If you look on the old solenoid, you will see something like I, S. What's the other one? Somebody help me. So I is for ignition, S is for starting, and what the other one is for? The other one is what? E for earth. And the old solenoid. You wouldn't know that, you're too young. You understand? So the letters tell you where to put what. Right? So it's always stamped on the star text. Right? So on the newer solenoid, you only have 2 connections, so or 3 connections. So and it's foolproof because the solenoid is grounded through the body of the starter. All right, so test light should glow when the key is turned to start position. All right, so if you go to the solenoid S and you put on the start and turn the starter key and the light comes on, right? But yet the engine start poorly, how you go about fixing that? Tell me how you go about fixing that.
If
Are
the
you
engine, if the engine start poorly, then I guess you'd have to either check the ground or the battery voltage.
Yes, but this is where you could run the same test, but not using the test light because the light comes on,
Right.
it don't tell you how much voltage you have there, you know?
True.
Because the light will light up still with a lower than normal battery voltage.
Right.
And this is why I'm saying to you that even if you're sure that you have light there, and you're still having issue, one thing you want to use is a multimeter to see the number. It is important because that will tell you the voltage drop in the circuit there right then.
Right.
So you're checking to see if there's any voltage drop within the circuit, because if voltage drop is there, then definitely you won't have that motor turning properly. So that's what we're talking about when we say always just use a multimeter when you're going through. You run a test with your test light, yeah, nice, look pretty good thing, and your ground side and everything good, but voltmeter. Practice using the voltmeter. I remember now if you do all them little tests, you know, fancy, expensive voltmeter. Just buy a little voltmeter and practice, you know? Get familiar with doing that because that saves a lot of time. Really, problem will keep power from the starter solenoid and prevent cranking. Windings or contact points could be faulty. Use a test light or voltmeter to test for voltage going into and coming out of the relay terminal. So remember we talk about that central point where we want to check to see if the problem is upstairs or the problem is downstairs. This is what we're talking about, right? So if you go to the starter solenoid and you check, and you see where you're supposed to see coming downstairs and it's not going out, you know where the problem is. If you're not getting where you want down there, you know where the problem is. And if you're getting coming down and you get it going out, you know it's the solenoid is the problem, right? Neutral safety switch service. You should put neutral safety start switch service because some vehicle will tell you about neutral start switch. Neutral safety start switch. Okay. A misadjusted or faulty switch can keep the engine from cranking. Right? Because remember now the neutral switch is a part of the circuit, and if not closed properly or making contact properly, then you won't have current flowing through the system. Right? So the neutral switch is just same like any on and off switch. You understand? Move the transmission gear shift lever into various positions while trying to start the engine. So you're going to make sure that your park brake is on. You're going to ensure that the service brake is fully applied, and you're going to hold the key in start position and shift the gear selector. All right, to see if you get to start in any other position other than where you're supposed to get stuck. If the switch allows cranking in the wrong gear, adjust it. Right? If it can't take any adjustment, it's between the cable and the neutral switch.
Cable and selector.
The selector cable and the neutral switch, yeah. All right, so switch testing. Touch a grounded test light to the switch output while moving the switch lever. All right? So I want you to be very careful when you're doing this test, especially with newer type vehicle, because some of them vehicle come through some IC for different control with information and data transfer. So test light usage, regular test light usage is not permitted for some of these tests, but we'll consult service manual for recommendation and instruction as how to go about that. Test light should glow if in park and neutral, right? So if it doesn't glow, it could be that you have a blown fuse. Simple as that. So we generally execute the simplest checks before we get to the complex. So we follow the KISS principle. Keep it simple or you end up stupid. All right? Test light should not glow in any other position. Right? Unless you change it from that point to the position that you're looking for.
Sir, so when you're using, instead of using a regular test light, could you use one of those that is what they call being computer compatible?
Yes, the light emitting diode,
Right.
LED, yeah, right. And avoid using the probe when you're doing some of those tests because you could accidentally send feedback to the modules and get them damaged. So you want to use your probe for actuator test, right? You could use it for starter. You could use it for seat. You could use it for wiper. You could use it for light from the relay. So activate the relay. You understand?
Right.
And stuff like that. Power window. Just go to the switch, and if you know the circuit, you go press quick, bam, 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 up and down the window, up and down. But you don't necessarily do that because scan tool now can do that. You understand? But if you don't reach a scan tool and you have a probe, you can articulate. You understand?
Right.
Yeah. All right, so starter service. Starter motor can cause several symptoms. Slow start, no start, overheating cable. And you notice how I go slow motion with that? Because even though the starter motor could cause overheating cable, right? That's excessive cranking. But what say this cranking is not excessive? It will come from a slack connection at the battery terminal. And between the battery terminal and the battery post, it comes from a slack connection at the ground connection, whether it be on the engine or the body of the vehicle. Right? So if you notice any one of the leads are getting hotter than normal, then you need to investigate. It means that you have excessive current flowing through the circuit. Right? And one of the reasons for excessive current flow is slack connection. Right? Or high resistance in any case. Right? And the other thing is noise. All right, so this is where you could have some problems with starter motor. These are some of the components within the starter motor that could give you a problem as we begin to operate the motor, right? So one of the It's the light, you know. Turn off the light. Turn off the light. The light not on.
Yeah, come on the computer screen now.
No man, it's not come on inside the light they can come to. Alright? So we could have a weak plunger spring. We could have a damaged plunger, so we're not making proper contact. We could have a damaged or worn pin. Right? We could have a damaged engagement arm, which is the same thing that we call the fault that throws out. Right? And we could have problem within the armature itself, or the field current, or the coils itself. Right? So these are just some of the checks that you must be able to execute to make sure that everything is all right. So remember, so when we check for short circuit, for open circuit, we check for short circuit just at the very same point. So if we were to check the armature for open circuit, we check the armature for short circuit, just the same. If we're going to check the coil for open circuit, we check the coil for short circuit, just the same. Okay, so starter motor removal. So we need to disconnect the battery, right? And we generally connect the battery, the negative side of the battery, on both the cable and wires, and screw bolts while holding motor, right? Note the position of any alignment shim. Remember we talked about that earlier, right? So we must make note of that. If possible, we mark, right? So we start a motor removal. When fasteners are hard to reach, a swivel extension or ratchet may help. Yeah, like nothing. All right. So only start up firmly because it is fairly heavy. Yeah, so while coming down, the weight might carry down and your hand or your finger on a piece of metal, and you may just get yourself injured during the process. So be mindful of that. If it carries a stud, it's easier than if it carries a bolt, because when you screw the bolt out, it comes down with it. While if you have a stud, you will take the nut off and then pull. But be mindful that it carries some weight, just the same, and it may tug you down. So you have top mounted starter rather. Remove the intake manifold to access the starter motor. Well, I don't know where's people. I remember I get one Tunja one time, couldn't find the starter. Couldn't find the starter. You was still the man and put the starter. You have to take off the whole plenum. It's right between the V and the under the plenum. That's where the intake.
Yeah, I know that.
Yeah, it's crazy. But this is why we say we consult, because we don't have the wherewithal, we don't know everything. So we generally consult for information so as not to waste time. So this is now where you will have to do your main servicing, right? To remove, clean, examine, change if necessary, service, and put back together and reinstall. All right. So you see that snap ring there? This snap ring here? A lot of people afraid for police. But listen, you need to ensure that you have the pinion gear sliding properly and the shaft and the armature. You understand? So it's important that you pull it, clean it, get rid of the whole grease out there, clean it, and put it back in there. and take your time and learn how to pull it and how to close it. Because if you don't know how to, then you're going to end up with a lot of damage to them fingers where you have them. I'm telling you from experience. So it's important that we have the appropriate tool. If we don't have the appropriate tool, we suffer. So we inspect parts for, so we are, okay. Inspecting parts, wear safety glasses, blow parts clean with compressed air, wipe components, do not use solvent and any damage insulate. Do not use solvent, it may damage any insulation or wash lubricant from the clutch. All right, so if you have to clean anywhere where the clutch is, we use just damp the cloth with some thing and wipe it. We don't use solvent on them. And anywhere where we have field coil or anything like that, we don't want to use solvent on them because they might just take away the insulation and then you end up with short circuits. Okay, so these are just comparing brush lengths, checking the specification of the brush to see if it's okay to use back or if they need to be replaced. Armature service, visually inspect the armature for damage, burn, rubbing, and the field pole and the commentator. So if you have any rubbing or anything like that, we would have to check like bushing for wear. We are more likely bushing because the shaft is more, the material that makes it, the shaft is more tougher. Then we check for short open and short to ground. Short circuit check for short circuit on a growler. So the growler would be a tool that you rest the armature and for both ends, so you can turn the armature slowly and you can make contact and make sure that you're making proper contact, and you can check all around to see if it's short or open, just the very same. Follow tool instruction. Old metal strip and axle blade next to armature. Rotate the armature. Blade should not vibrate. Blade will vibrate when pass over a shorted leg. So this is what a growler looks like. So that's the axle blade there, or the metal strip, whichever. And that's the armature on the growler. So what they do is turn it and then you check for if there's any vibration on the metal strip. If that's the case, you need to replace the growler, the armature, sorry. Open circuit check, use a growler, lead or ohmmeter. Touch meter lead to each commutator segment. Light should glow. If infinite resistance is indicated on any segment, open circuit, the winding is open. So that's that's them running the test on the segment of the commutator. Right, so you go across each segment, then what you will do is hold on one segment and you walk the other lead around it. Right, if ohm exists between any commutator segment, replace the commutator armature. Short to ground check. Use growler leads on the ohmmeter. Touch lead on the coil core at the commutator segment. Light should not glow. Continuity or low resistance indicate grounded armature. So this is testing for short. So we're checking for short on both ends of the armature. So from the armature, from the commutator to the bigger part of the armature, and from the commutator to the armature shaft. So we check for ground between the core and the shaft and the commutator. Commutator is in good condition, may be sanded with fine sandpaper. Oh, fine, fine. A badly worn commutator may turn on a lathe, and the insulating mica between the segments, uncut using a special tool or axle blade. And that's the process and the machine shop. Just a minute. So here we are with the armature and the lathe. And we are cleaning the commutator. So we use a suitable grade sandpaper for this. And we can also check the diameter using a vernier caliper to check the diameter of the commutator. So this is the mica depth of the commutator. And that also tells you the integrity of the commutator. If it is able to withstand the workload that is thrown on it, or it will need replacement soon. Okay.
How would you check the mica depth?
Okay, so and in most cases you would have like a depth tester, but you could what you could do is you could clean, well, definitely you would have to clean the ear first, and then you would have a depth tester that check the depth between the
top and bottom
segments.
Right.
Yeah. So yeah, go ahead.
And they should basically all be the same depth.
Yeah. Yes. If it's not, then you're gonna have sporadic voltage difference.
Okay.
Because the brushes are not making proper contact across the surface.
Okay.
Anything else anybody else would like to ask? We're going to leave you here for this evening, and we'll pick up at the next class.
Just quickly before you go, so how would you know what is the right depth?
Okay, so like I said, you would consult the service manual. The service manual will tell you for what vehicle, what the depth should be, and even with the diameter, what the diameter should be. It will also tell you the grade sandpaper to use for cleaning. I use Scotch-Brite or steel wool.
Right.
Yeah, I don't want to take off any material where I don't have to.
Sure.
You understand? So, but we generally use what the makers tells us to use.
Yes, sir, I can use sandpaper.
Yeah, we could use fine sandpaper also.
Okay.
Okay.
Everybody is good?
I am.
All right. It's always a pleasure serving you. And I look forward to seeing you at the next class.
Okay, sir. Take care. Thank you.
All right. Have a good night.
Yeah, same to you, sir.
All right, good.